So I gave you a few words on the neoclassical model and the solid model in particular, just a kind of bit of background. I'm now going to give you another bit of background on the solo, which is about the properties of the Cobb-Douglas. So in the Cobb-Douglas, we say, typically we would say that y is ALL to the 1 minus alpha k to the alpha. So we're basically saying that the stock of widgets always has the same productivity per widget, but labor productivity can grow. Okay. And an interesting property of this is what we call the unit elasticity of substitution, and I'm just going to go through that here. So what is an elasticity of substitution? So what is an elasticity? An elasticity is the sensitivity of quantity to price, isn't it? Sensitivity of quantity to price. It's like dq dp times p over q, if you like. So what's the elasticity of substitution? It's the sensitivity of relative quantity to relative price. So relative quantity is like L over K, and the relative price is like WL over WK. Where WL is the wage and WK is the cost of hiring capital for a period. Cost of hiring a unit of capital. So it's the sensitivity of the relative quantity to the relative price. Okay. So, how do we work this out? Well, we need expressions for WL and WK, don't we? And how do we get those? Well, to get those we need to make some assumptions, and we make the typical assumption, which is that there are perfect markets. So you've got a firm, a representative firm, which is like representative of all the infinite number of small firms in this economy with perfect markets, which is trying to maximize its profits, which is PYY minus, so this is its revenue, isn't it? And then minus the costs of buying or hiring the inputs. Hiring labor and capital. Okay. And Y is just this, isn't it? So then we take the first order conditions in L and K to derive the following expressions. So actually, I'm just going to rewrite this. I think it might be easier for you guys. So PY times ALL. But the firm's a price taker, right? So PY is exogenous to the firm. And typically we'd normalize that to 1. Yeah. It's good to be aware of the fact that it's there, even if we've wiped it out. In the course, I'll often leave that in, or sometimes anyway. You should be aware that it's there. Okay. So, what is the pi by the L? Now, I'm going to talk about how to differentiate here. You all know how to differentiate, but I'm going to teach you how to differentiate like an economist. Because in economics we're typically interested in elasticities, which basically means we want to know the sensitivity of this, which is just y, to the change in the quantity of input. So we want to keep y in the expression. So d pi by dl. We've got an L to the 1 minus alpha here, haven't we? So you'd say 1 minus alpha times AL to the 1 minus alpha, L to the minus alpha, K to the alpha. I guess that's what you would do. But I don't do that. I say it's 1 minus alpha times what we had to start with, which is just y, divided by L. Which is exactly the same as 1 minus alpha, AL to the 1 minus alpha, L to the minus alpha, K to the alpha. If you can't see that straight up, think about it carefully, work through it on paper if you like. It's the same thing. So that's that, and then when we differentiate this, we get minus WL, and for the first order condition for a turning point is that those are equal, which tells us that, right? And then the same process for K gives us alpha times y divided by K is WK. So if we put those together, we can get, after a tiny bit of algebra, so if we divide one by the other, okay, we get, and do a tiny bit of algebra, we get that L over K is 1 minus alpha over alpha WL over WK to the minus 1. Okay, you might need a couple of steps to do that. So now we're in a position to work this out, aren't we? dL over K by dWL over WK is just minus 1 times what we started with, which is L over K, divided by WL over WK. So, and actually we put a minus sign here so that the value of it becomes positive. So then we can say that eta equals 1. This is eta. Eta. So the elasticity of substitution between the inputs is 1. Another way of thinking about it is, from here, we can say that WLL over WK is 1 minus alpha over alpha, which means that returns to labor and returns to capital are constant relative to one another. Firms hiring labor and capital will always spend a fraction alpha of their expenditure on hiring capital and a fraction 1 minus alpha on hiring labor, whatever the relative quantities of capital and labor. So basically, if the quantity of labor, say, goes up, that means you hire more labor, but you have to pay less for it because labor gets cheaper, and the two effects cancel each other out, and the relative amounts you spend stay the same. So that's the unit elasticity substitution.